Hello. Today we're talking about adding probabilities. Now, I want to go over real quick. If two things are happening, two events, then the probability of A happening first, then B happening, is where you multiply the probabilities together. First A has to happen times the probability of B happening. Okay, if we get a different word, if we get an or word, if the probability of A or B could happen, then we're going to add them together. The probability of A plus the probability of B. So if it's an and, we're multiplying. If it's an or, we're going to be adding. Okay, so if I have a deck of cards, and I'm looking to draw either a 2 or an ace, find the probability of drawing a 2 or an ace. The very first thing I'm going to want to do is to say, what are the two separate probabilities? The probability of drawing a 2 and the probability of drawing an ace. Let's add them together. So there's 4 2s, one of every suit, out of 52 cards. So the probability of drawing a 2 is going to be 4 out of 52. Same with an ace. There's 4 aces, hearts, diamonds, spades, and clubs. And so out of 52, I add those together. The probability of getting a 2 or an ace is 8 out of 52, or you could say, simplify that to 2 out of 13. Still unlikely to happen, but pretty simple to put together. This is an example of what's called mutually exclusive, and basically, it can't happen at the same time. So you're either going to draw a 2 out of the pile, or you're going to draw an ace. You can't have a 2 and an ace in the same card. Okay, what happens if you have 3 mutually exclusive events? So here's a little complicated example. There's 7 girls, 6 boys on the junior class homecoming committee. A subcommittee of 4 people is being chosen at random to decide the theme for the class float. What is the probability that the subcommittee will have at least 2 girls? So at least 2 girls means that the subcommittee may have 2, 3, or 4 girls. And it's not possible to select a group of 2 girls, a group of 3 girls, and a group of 4 girls all in the same 4-member committee. So they're mutually exclusive. So the first thing we have to do is we have to say, okay, what's the probability of each of those groups? 2 girls plus the probability of 3 girls together plus the probability of 4 girls. Okay? So to put these together, when I have 7, and sometimes you'll see it like this, other times you'll see it as the combination. I've got 7 girls to pick from, and I'm picking 2 girls. When that happens, I need to find out how many combinations of 2 boys are also possible. So 6, choose 2 boys. Multiply those together. And then that's how many 2-girl groups are possible. We will divide that or put that over how many groups are possible, period. If there are 13 people and I'm choosing 4 people at random. Likewise, for 3 girls, there's 7 girls to choose from, and I'm going to choose 3 of them, and I'm going to have 6 boys to pick from, and I want to see how many if I pick combinations of picking 1. Put that all over the same 13, choose 4. And if I'm picking all 4 girls, then there's 7 girls to choose from. I'm going to find how many different combinations of 4 girls there are. And if I'm picking no boys, well then 6 choose 0 is just 0, or just 1. So it's 7 choose 4 out of 13 people to choose from, picking 4 people. Now, you'll notice it gets a little overwhelming at first, but when we're adding these, one thing you have to have when you're adding fractions is a common denominator. Notice how the probability is the same already. We have a common denominator, so we just need to add them. So we put these together, and we find out that 315 out of 715 is the probability of picking 2 girls. 210 is the probability for picking 3 girls, and 35 over 715 is the probability of picking 4 girls. Add those all together, you get 112 out of 143 is what it reduces down to. So you can estimate that, or you can to be about 78% chance of at least 2 girls being on there. That's pretty likely. Okay, mutually exclusive events. Now, mutually exclusive events can happen at the same time, in which case, so if I give you the probability of drawing a queen or a diamond, you can have a queen of diamonds. So if I look at here, there are 4 queens. The probability of picking a queen is 4 out of 52. There are 13 diamonds, and so the probability of picking a diamond is 13 out of 52. But the trouble is that this group includes a queen of diamonds, and this group also includes a queen of diamonds. And so this is getting counted twice if we keep them together. So we need to find out what's the probability of just that one queen of diamonds that's happening. Well, there's one queen of diamonds out of 52 cards, so what we're going to end up doing is we're going to add the probability of getting a queen with the probability of getting a diamond, but then we need to subtract out our double case, what gets counted twice. So what we're going to do is we're going to go 4 out of 52 plus 13 out of 52, and then minus out that extra case that got double counted. So that way, everything will only get counted once. And then 4 plus 13 is 17. Minus 1 is 16 out of 52. And we can reduce that and divide them both by 4. You get 4 out of 13. So the probability is 4 out of 13 of drawing a queen or a diamond. Okay, so what if we have an example like this? Lisa has 9 rings in her jewelry box. 5 are gold and 4 are silver. If she randomly selects 3 rings to wear at a party, find the probability. Okay, she's got 9 altogether. She's picking 3 of them. So what's the probability that she picks 2 silvers or 2 golds? Well, silvers. If she picks 2 silvers, there are 4 silvers to pick from, and I'm going to pick 2 of them. However, if she's picking 3 rings, we need to include the gold. So we need to say how many gold rings are there. 5 gold rings, and we're picking 1 of them. Multiply those 2 together. Now, that's our top number. That's how many combinations of 2 silvers there are. We need to find how many possible combinations total. So there are 9 rings to choose from, and I'm going to choose 3 of them. So that is for 2 silvers. Now, if I'm going to pick 2 golds, I need to know, okay, there are 5 golds to pick from. So let's find the combinations of 2 picking 5 out of 5 golds. But if there's 2 that are gold, that means there's going to be 1 silver. So 4 to pick from, and I'm going to choose 1 of those silver ones. That's how many combinations there are for picking 2 gold rings. How many possible? There's 9 total, and we're picking 3. So the OR means we are going to add these together. Then, let's work through this. I'm going to use a shortcut. So finding combinations, we're going to find 4 times 3. I'm only choosing 2 of them. And then divide by that second 2 for the extras, that 2 factorial, which is 2 times 1, times 5, choose 1 of them, divided by 1 factorial, that's just a 1, all over 9 times 8 times 7, 3 of those, divide by 3 factorial, plus, and then let's go over here, 5 times 4, I'm only picking 2 of them, divide by 2 factorial, times 4, and I'm only picking 1, so divide by 1 factorial, all over the same 9 times 8 times 7, I'm choosing 3 rings, and divide by 3 factorial, 3 times 2 times 1. So now let's do a little simplifying. The 2 and the 4 cancels out, leaves a 2. 2 times 3 is 6, times 5 is 30, over, we can simplify that with a 3. This simplifies, makes a 4. 12 times 7 is 84, plus, we know this is going to be the exact same, so we'll have 84 down here, and then 2 divided by 4 is a 2, 5 times 2 is 10, times 4 is 40. So the probability of these is 70 over 84. Good luck. I hope this helps.